Hello, today we are talking about some actual derivatives that you need to memorize. So what I mean by that is, for example, if we have the function y is equal to sine x, and from this point forward I ask you for the derivative of that, is y prime equals cosine of x. And again, that's the function. So from here, I could say, tell me the derivative of sine of x at, so hold on, let me write it down. You don't have to. Derivative of sine of x at x equals pi over 2. And then you can go, okay, I know the derivative of sine of x is cosine of x. So my answer would be cosine of x, but I know x is at pi over 2, so I plug in pi over 2. And then I could evaluate cosine of pi over 2, which you should know is 0. So that's what this would be used for. I'm going to go ahead and erase that just as my example of what's going on now, what's different. So again, these are just the derivatives that you need to memorize, and again, they will be the functions. Not at an actual point, but they will be used to find the derivative at an actual point. So again, if you start with sine of x, the derivative of that is cosine of x. If you start with the function cosine of x, the derivative of that is the opposite of sine x, or negative sine x. If you start with tangent of x, then your derivative is secant squared of x. And these are the two ways that you can write it. Typically, we're lazy mathematicians, so we usually write it in the second notation, but that means the first notation. Now, the x is not what's being squared. The secant of x is what's being squared. We have the next set down below. If you have cosecant of x, its derivative is the opposite of cosecant x cotangent x, or in other words, negative cosecant x cotangent x. If we have secant of x, that derivative is secant x tangent x. And if we have cotangent x, its derivative is either one of these. And again, the lazy mathematicians use the bottom notation, the opposite of cosecant squared x, or negative cosecant squared x. Again, these are ones that you need to memorize. I'm going to scroll down. And what I'd like you to do is right here, I would like you to take a moment to find the similarities and the differences between these functions and these derivatives. So there's a way you can kind of group them. So all of these functions, their derivatives do this. All of these functions, the derivatives do this. Or these functions, their derivatives are similar. So I would like you to take a minute and go ahead and group these functions based on their similarities and differences. So please pause the video here. So moving on, we have some other derivatives. We have two others that need to be memorized. And this one, hopefully everybody can memorize this one. I can. So if I start with the function y equals e to the x, its derivative is also e to the x. It doesn't change. Its function and derivative are the same. And I also have natural log. If I have y equals natural log of x, the derivative will be 1 over x. Now, because we've introduced natural log, we probably need to talk about a couple of the rules. And again, these are rules that you need to know. So you kind of have to memorize these. If you're going to memorize the other stuff, add this in. Natural log of 1 is 0. Natural log of e is 1. Natural log of e to the x is the same as just x. Natural log of y raised to the power of x means I can bring the x down in front times the natural log of y. Natural log of x times y is the same as natural log of x plus natural log of y. And natural log of x divided by y is the natural log of x minus y. And again, put that on your list to memorize. We'll move on to the next page. So here what we're doing is we're connecting our new information with the old information that we have already done, and we did this with the power rule. So for example 1, if I have f of x is sine of x, and then we're going to show what the limit, this limit looks like, which is the definition of derivative. And let's show what it looks like for this particular function. And then we've added this to these. State the derivative. Okay, so we're going to have f prime of x is going to be equal to sine of x plus h minus sine of x all over h, and I forgot the part that I always forget, the limit as h approaches 0 should be right there. So I say, okay, I know my function is sine of x. I'm trying to find the derivative. I plug that into the definition of derivative, and then I go, wait a minute, this is one that I was supposed to memorize. I'm going to go back to the front. Hold on. Back to the front. And I go, oh, if I have the function sine of x, its derivative is cosine of x. Back to the back. So I know that this is equal to cosine of x. So this is our additional step that we have added. So let's go on to example 2. So for example 2, we have the other definition of derivative, and I am finding this derivative at pi over 2. So I'm going to have f prime, instead of x though, I'm not going to say f prime of x, I'm going to say f prime of pi over 2 is going to be the limit as x approaches pi over 2 of sine of x minus sine of pi over 2 all over x minus pi over 2. And then I'm going to do a little side work. I know that if I have f of x is equal to cosine of x, sine of x, I know that derivative is cosine of x, and I want to find the derivative at pi over 2, so that's going to be cosine of pi over 2. Oh dear. Sorry for my technical difficulties. That's cosine of pi over 2. So what this is going to end up being is cosine of pi over 2. And again, we already know what that is, and that is 0. So next one. For this one, we're going to show what the limit looks like, and then we're going to find the derivative. And this is a power rule, so we've actually already seen one like this. So we have f prime of x is equal to the limit as h approaches 0 of something squared minus 4 times something plus 7. And I'm plugging in x plus h. And then I'm subtracting the function, x squared minus 4x plus 7, all over h. And this one, do I know this derivative? Well, this isn't a sine or a cosine or an e to the x or a natural log, but it is a power rule, so I should be able to find its derivative. So its derivative using the power rule would be 2x minus 4. And that's my derivative. On to the next one. I believe it's the same thing, except now we're at a point. So please pause the video and complete example 4. Here's the solution. If you got this correct, we're going to keep on rolling with the video. If this is not correct, please pause the video here, make any corrections, or write down any questions. Next page. So we're going to complete each definition of derivative, and before you complete each one, decide whether your answer should be a number or a function, and write either N or F. Now, the one that I'm going to do right now is going to be number 2. So first of all, is this a number or a function? So take a second, take a look, and decide a number or a function. And when I look at this, I know that this is the f prime of c form of my definition of derivative because I have a subtraction here, and m is going to 5, which is also a clue, so that's going to be a number. And then I'm going to complete this definition of derivative, so I need to identify what this means. This is a derivative of what function? Of natural log of m, which means I would write it as f of m is natural log of m. And so I want that derivative, and I want it at m is equal to 5. Okay, so if I start with the function natural log, I know what that derivative is. Go back to the other page if you don't remember. I know that f prime of m is going to be 1 over m, and I want it at m equals 5, so f prime of 5 is going to be 1 over 5. And this is what you're going to do for all of these. I'm just going to take a quick look. So these look wonderful, and I'd go ahead and try a couple of these. I'm going to provide you with the answers in class, but I would like you to try just a few. Okay? Have a nice evening.